Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be solving our equations by factoring. Specifically, these are quadratic equations, and the reason being is this little exponent right there. Because that exponent is a 2, and it is the largest exponent for all of our terms, this is a polynomial of degree 2, and a degree 2 polynomial is called a quadratic. So we are solving our quadratics by factoring today. So let's go ahead and begin. When we are solving by factoring, we're going to want to keep in mind this factoring flowchart. The very first thing that we always want to begin by asking ourselves is there a GCF? In example number 1, from these 3 terms, is there something that we could divide out from each of them? No, there is not. So we move on to the next part. There is not a GCF. Our question next is there a difference of squares? Is it a difference of squares? Well, no, because what we have is 3 terms. We don't have a difference of 2 squares. No, it's 3 terms inside. Okay, so because there's 3 terms inside, the question is, does our A equal 1? Well, ladies and gentlemen, by A, what we are implying is a quadratic equation is always written in the form where you have your your A x squared, and then plus your B x, and then last of all, your constant, which is C. So what is the A value in this case? What is our A value? It's whatever is here in front of our x squared. What number is in front, of that y squared? It is the almighty 1. Our A is 1. Our B is this negative 13. And our C, our constant, is negative 30. So with that, because the A is equal to 1, you're going to find factors that multiply to get us C and add to give us B. So what does that look like, ladies and gentlemen? We are asking ourselves, what is going to multiply to give us C, which is negative 30, but add to give us B, which is negative 13? What 2 numbers will complete our cross? Multiplying to give us negative 30, but adding to give us a negative 13. All right, well, the correct response would be a negative 15 and a positive 2. So, ladies and gentlemen, we write our factors with the format x plus or minus the value that we found, and that is multiplied then with our second x plus or minus that number value. And so that looks like, in this case, y minus our 15 and y plus 2 equaling 0. All right, now ladies and gentlemen, we utilize our zero product property. Remember that if you had 2 things, let's call it P and Q, if they equal 0, well, what does that mean? Then P can equal 0 or Q can equal 0, because that's the only way that you will have a product of 0. The only way to have a product of 0 is if, when you take those 2 numbers and multiply them together, one of them was originally 0 to give you a product of 0. So using that property, we will say that, well, y minus 15 equals 0, or y plus 2 equals 0. That means, ladies and gentlemen, that y equals, solve it. What's that going to be? If you add the 15 on each side, y is 15 and y is negative 2. The solutions to this equation, the values that make it true, that make it equal 0 are negative 2 and 15. Those are the values in our solution set. So there you have it, ladies and gents. That is our first example. Let's take a look at our example number 2. Now, it is very important. We need to have our equations such that it is equal to 0 in order to utilize this property that we see down here. If we're going to use this 0 product property and set each equal to 0 and then solve those two equations, it has to be, right? It has to be that the equation equals 0. Right now, it is not set equal to 0, so we need to go ahead and make it in the form that you see here at the top. We need it to be written in ax squared plus bx plus c form. That means we need to subtract 80 on each side. Our new equation would then be 2x squared plus the 6x minus 80 equals 0. All right, that is the equation that we are going to be working with. So let's begin factoring. Is there a GCF? Is there something that we can divide out from all of those terms? There absolutely is. They're all even, so we can divide out a 2. All right, now look at that trinomial that is inside the parentheses. Let's continue to try and factor there. Is what is inside a difference of squares? No, because it's got 3 terms inside. So because there's 3 terms inside, then we ask ourselves, is our a value equal to 1? Well, let's go ahead and label it and see. We've got our a, which is the value in front of the x squared, and then your b, and then last of all, your c value. What is the value for a? Again, there is an almighty 1 in front of that x squared, so this is going to be the quicker factoring, because when we have that a equal to 1, our final answer looks like 2 binomials that both start with x. So we're going to have 2 binomials that both start with x, setting that equal to 0. Don't forget your GCF, that's still out front. But let's go ahead and find what those numbers are. We need 2 numbers that multiply to give us our c value, which is negative 40. Our c value, which is a negative 40, and add to give us our b, which is 3. What multiplies to give us a negative 40, but adds to give us 3? All right, well, one of them is going to have to be positive and one will be negative. That's going to be a positive 8 and a negative 5. And that'll finish our factors. Now we will set those expressions that include x equal to 0 using that zero product property to solve for the values of x that make our equation true. What are those values of x, ladies and gentlemen, when we solve each of these? X would equal a -8 and x would equal 5. So we'll write our solution set here that x is going to be the set -8 and 5. There you have it. Let's take a look at the following. Example number 3. All right, example number 3. Let's go ahead and first of all, make sure that it's rewritten so that it is set equal to 0. When I rewrite that, that means I'm going to have to add 10w on each side. So my new equation is going to be 4w squared plus 10w equals 0. Okay, let's begin to solve by factoring. Is there a GCF? If there is, factor it outside of those parentheses. Do we have a GCF? We most certainly do. What can we divide out of 4w squared plus 10w? That's going to be a 2w. Inside will remain a 2w and then plus 5. That is all equal to 0. All right, now, can we factor any further? Inside of the parentheses, can that be factored anymore? It cannot. It is linear. This has not been raised to any kind of exponent, so it is completely factored. Now let's go ahead and use our zero product property and set each piece that in each of those factors, set them equal to 0. All right, and let's go ahead and solve. If we are solving that first, it's going to be dividing by 2 on each side, which gives us w equals still just 0. Here we're going to need to, with our second equation, subtract 5 on each side, which gives us 2w equals -5. And then our final step, divide by 2. And we have that w equals -5 over 2. Our solution set is going to be w being -5 over 2 and 0. Just about done, y'all. Let's look at this final example here. All right, what is it that we need to do first? What do you guys think we should do first of all? Well, like we wrote at the top, it needs to be so that that equation is equal to 0. So I'm going to need to pass these terms to the other side, subtracting 4 and subtracting p, so that then we have 5p squared minus a p and then minus a 4 equal to 0. I want it to be in descending order so that my squared term is first, my linear term is second, and then my constant, my number, is last. All right. So now that it is written in the correct form, let's go ahead and try to solve by factoring. Is there a GCF? Is there a GCF? Is there something we can divide out of all 3 of these terms? No, there is not. So is what is inside a difference of squares? No, because there are 3 terms inside. Now, since there are 3 terms inside, is A equal to 1? Is A equal to 1? Let's go ahead and label these. A, and then our B, and then our C. Ooh, ladies and gentlemen, look at that. Our A is equal to 5. Our A is equal to 5, so we're going to need to follow the how to factor when we have a no GCF trinomial. That looks like using the cross to expand that middle term. So it looks like this. Your B is still going to be in the bottom. What is our B? What is the number in front of P? What is that number in front of P? It is a -1. It is a -1. This is really a -1P. And then on top, you want to take the product of A times C. The product of A times C which gives us a -20. All right, so what is going to multiply to give us a -20 and add to give us that value of B, which is -1? What's that going to be, you guys? All right, well, I'm going to have a negative and a positive, the bigger one being negative, and that is 5, and a positive 4. Let's go ahead and rewrite our equation here. So we have 5p squared, and then we take this value here and this value here, and we use it to rewrite our middle term. So instead of a b value like so, we're going to rewrite it as a -5p plus 4p, and then finish writing your equation. -4 equals 0. All right, look real carefully here. Let's go ahead and, from our first group, identify what could we divide from the first group. What can we divide out of that first group? What would be that GCF from the first? They both have a 5 and they both have a P. Left inside will be a P minus 1. If you multiplied 5 times P gives you that 5P squared. 5P times the -1 gives you that -5P. From our second group, what would be the GCF? From our second group, we have a GCF of 4. And inside, divide out a 4 from the first term, all that's left is a P. Divide a 4 out of -4, and that's a -1. So one of our factors is the P minus 1. The other factor is 5P plus 4. Both of those are multiplying and equals 0. So using our zero product property, that means that P minus 1 is equal to 0 and 5P plus 4 is equal to 0. Our values of P that make our equation true, well, if I add 1 on each side, that gives me my P value of 1. And taking 2 steps here, we would have 5P equaling -4, and finishing it off by dividing P equals a -4 over 5. So our solution set for P is -4 over 5 and 1. There you have it, ladies and gentlemen. That is solving by factoring. I really hope that this factoring flowchart is helpful for you as you work to solve quadratics through that factoring process. If you had any questions, please take some time right now to share. And until next time, stay fired up.